the modern software development landscape. It's this profound paradox of choice. Everywhere you look, there's a new tool, a new framework. They all promise to, revolutionize everything. And it can leave you feeling, well, confused, genuinely stressed by just the sheer number of options, especially when you're trying to build with AI.
It really is that feeling of always chasing the next shiny object. So our mission in this deep dive is to just cut through that noise entirely. We're going to synthesize a complete integrated text, a set of tools that's been rigorously tested for over a year, and it's focused completely on building applications with AI first.
So this isn't just a list. It's more of a battle-tested blueprint for creating, say, robust AI agents or scalable algorithm systems.
Exactly. And the core philosophy is simple. Focus on what a tool enables you to do, not just the tool itself. We're all about solving real problems, not chasing microtrends. So we'll start with the non-negotiable foundations databases, caching, then move into the specialized stacks for agents and RAG, and we'll finish with deployment and some really powerful local tools.
Okay, let's dive into that foundational layer. The application's main filing cabinet, the database. It seems like we're shifting back to a classic choice here.
It's the big SQL comeback. Yeah. We're seeing PostgreSQL, usually through managed services like Neon or Supabase, really become the standard for new AI apps.
But why the hard pivot back to SQL?
Yeah.
I mean, for years, NoSQL, things like MongoDB or Firestore, they kind of dominated the startup scene because they were so flexible.
Right, but this is a crucial shift for an AI-first stack. Large language models they understand structured relational data extremely well. So when you ask an LLM to write a query to go get some data, it does a brilliant job with SQL. And that switch, it just dramatically simplifies that whole interaction layer between the AI and your data.
So the LLM is basically acting as this sophisticated query generator that just happens to be fluent in PostgreSQL. That's a huge performance benefit.
Exactly. And speaking of foundational tools, you need that short-term memory for speed, right? Caching. Redis is still the industry standard there for just lightning-fast lookups. Now, if you're building an entirely open-source stack and you need to run everything locally, its drop-in equivalent is Valky.
But using Redis, that introduces a dependency on one vendor, even if it is an industry standard. Does Valky sort of mitigate that risk for teams that are really focused on an open-source architecture?
Absolutely. For enterprise-level stuff, Redis is often fine. But Valky gives you that freedom, that true self-hostability, which is vital for a lot of large-scale open-source projects.
Okay, so moving into the actual building process. The most consistently used tool in the source material seems to be the AI coding assistant, Claude, paired with your open-source project, Archon.
Oh, Claude is probably open on my machine more than my IDE.
Yeah.
And yeah, Archon is just a set of open source scripts and guidelines. It helps you manage your API keys, usage rates, and context windows when you're dealing with big models like Claude. It just keeps the whole process clean.
The key here isn't just using Claude, though. It's how you use it.
Precisely. We have to move beyond these vague requests. So instead of asking, how do I make a button? You ask for a specific React component, call it primary button, that uses Tailwind CSS for styling, accepts 3 specific props for text and clicks, and includes a precise hover effect. The accuracy of the ask really dictates the quality of the result.
You're tailoring the AI to fit right into your existing stack immediately. But before you even commit to code, prototyping is recommended using a no-code tool. N8N.
Yeah, think of NAN like visually stacking Lego blocks to test out your logic. It's perfect for quickly mocking up an AI agent idea, checking if a tool works, or testing system prompts before you invest any time writing production code. Plus, it's open source and self-hostable, so it's a great risk-free step in the middle.
So just to circle back, since LLMs prefer SQL, does that mean NoSQL databases are functionally dead for new AI projects?
No, but SQL, like PostgreSQL, simplifies LLM data interaction dramatically. It's a huge productivity boost.
That definitely provides some clarity. Let's move from the foundation into the core stack for AI agents themselves, how we build and manage them.
Okay, so for the frameworks, you have to distinguish between the individual agent and the coordinator. For the individual agents, the workers, the choice is Pydantic AI.
And why Pydantic AI? There are so many wrapper frameworks out there.
Pydantic AI offers maximum control without what we call abstraction distraction. A lot of frameworks make you fight their own complex rules just to get basic stuff working. Pydantic AI gives you the flexibility to build reliable agents without the tool getting in your way.
Right. And once you have those capable individual agents, you might need a central manager.
Yeah.
And that's where LangGraph comes in.
Yep, LangGraph connects multiple Pydantic AI agents for those more complex multi-agent systems. It's built to manage the state, tracking what's happening across agents and making sure they follow a workflow. But the critical advice from the source is, don't over-engineer. Only use multi-agent systems when you really need to. Start simple.
Managing complexity is the priority. Got it. Now, let's talk security, especially when these agents are interacting with sensitive user accounts like Gmail or Slack. We need a security guard.
Tool authorization is essential. We use Arcade for that. It acts as the security guard, automatically handling the secure OAuth and permissions. So when your agent needs permission to read a user's inbox, Arcade makes sure that whole process is secure and the permissions are really detailed. There aren't many alternatives that do it so seamlessly.
Okay, and once the agents are deployed, knowing if they're actually working efficiently is critical. That brings us to observability with Langfuse.
Observability is just non-negotiable in production. You have to be able to see what your agents are doing. Langfuse monitors token usage, total cost, latency, all the tool calls. I still wrestle with prompt drift myself. Without Langfuse, debugging agents in production it's almost impossible.
Hey, hold on. For listeners who might be new to production AI,
Yeah.
what exactly is prompt drift?
Prompt drift is when an agent, over many, many runs, starts to deviate from its original instructions or it behaves unpredictably, and that usually leads to a drop in performance. Langfuse is really the only way you can catch that early.
So for a beginner, is observability really necessary right from the start, or is that something you can just layer on later?
Yes, because monitoring cost and latency is essential early on. You really don't want unexpected bills.
That's a very practical motivation. Let's pivot now to Argy Retrieval Augmented Generation, which is how we give the AI that open book exam to make sure its answers are factual.
Right, and the first step in Argy is clean data extraction. The decision here is pretty simple. If you're dealing with complex documents like PDFs, Excel files, you use Docling. It's a great framework for pulling clean data out of messy, structured files.
And for websites?
For web data, you use Crawl4 AI. It's fast, really efficient, and it automatically handles that crucial step of cleaning up all the junk, the ads, the navigation menus, so you're left with just the core content for the AI to ingest. So, Docling for files, Crawl4 AI for the web.
This brings us back to the vector database. It searches for similar concepts and meaning, not just exact words, and the sources recommend sticking with PostgreSQL and the PG vector extension. Why would you skip a dedicated, faster vector database like, say, Pinecone or Qdrant?
This is a really pivotal architectural decision. Most RAG systems, they need both a normal SQL database for user data and a vector database. By using PostgreSQL with PG Vector, you only have to manage one scalable database instead of two separate systems. The slight speed trade-off is it's overwhelmingly balanced by the huge savings in development time and maintenance headaches. Simplicity wins.
So the trade-off is really about developer efficiency and maintenance. That's a very pragmatic choice for a battle-tested stack.
Absolutely. And that simple unified architecture, it also supports long-term memory through a tool called Mem0. Mem0 is a framework that turns that PG vector database into the agent's memory bank, which lets it recall previous conversations or user preferences over time.
Now here's where it gets interesting. Knowledge graphs. This is an advanced technique using Neo4j and Graffiti.
Right. A vector database finds similar text in a document. A knowledge graph finds relationships between different pieces of data. It's fantastic for complex reasoning queries like, who worked with Steve Jobs at Apple after 2010 who also founded their own company? Neo4j is the dedicated graph database for that.
But how does the AI process and store that relational data in the first place?
That's where Grokkity comes in. It helps the LLM structure plain text by identifying these subject-verb-object triples. It's basically mapping entities and their relationships accurately so they can be stored in the graph. It takes you far beyond simple keyword searching.
Whoa! Imagine a single AI agent connecting a knowledge graph to understand complex hierarchies, then fetching a real-time price using Brave Search, and scoring its own faithfulness with RAGs. That's some serious power being managed there.
That brings us right to quality control. RAGs. You can't optimize what you don't measure. RAGs scores your RG system based on specific metrics like faithfulness, which means, is the answer actually verifiable in the source material? And relevance to the user's question. It's really specialized for measuring RG performance.
And finally, when the agent needs current, real-time facts from the internet, what's the choice?
The Brave Search API. It's privacy-focused, it doesn't track you, and crucially, it maintains its own independent search index. This gives the agent fresh, unbiased information when it needs current context, making sure that open book exam is always up to date.
So if dedicated vector databases are significantly faster, why accept that speed trade-off for architectural simplicity?
Because managing one scalable database, PostgreSQL, saves monumental development and operational time.
Welcome back to the deep dive. We've covered the foundational architecture, agent frameworks, and RA systems. Now we're shifting into the final rapid segment: web automation, full-stack choices, and essential local dev tools.
Okay, let's start with automation. This part is about agents that actually control a browser, clicking buttons, filling out forms, navigating complex UIs, not just reading data. For deterministic, predictable, step-by-step scripting, Playwright is still the industry standard. It's super reliable for that kind of scripted automation.
But where does the AI truly take control of the browser?
That's Browserbase. And this is powerful. You give the agent a natural language task like log into my account and download the monthly statement. And Browserbase controls a secure browser environment to complete it. All the sessions are recorded for debugging, and it has built-in anti-bot detection, which is vital when you're scraping or interacting with modern websites.
Okay, shifting to the full stack. Given the agents are Python-based, what's powering the API layer?
FastAPI. It's a modern, high-performance API framework in Python. It's just faster and cleaner than older alternatives like Flask, and it keeps your stack cohesive since the agents are already in Python. And then on the front end, the recommendation is React with simple, fast, and importantly, AI coding assistants have massive training data on React, so code generation is highly reliable.
And for styling, it's that standard component set of shadowlation running on Tailwind CSS.
Yeah, that combo makes building beautiful UIs really fast. But here's an interesting specialized tool, Lovable. Claude is great for logic and code structure, but Lovable is an AI agent that's specifically optimized for generating beautiful, aesthetically pleasing user interfaces. Its training is all about design patterns, so it fills that gap where general LLMs often fail on visual detail.
And before committing to that full React build, the source really stresses using Streamlit first.
Streamlit is the ultimate rapid UI prototyping tool. It lets you build a full interactive UI like a test chat box or data dashboard directly in Python with minimal code. It's the easiest way to test your agent's functionality and user experience before you graduate to the complexity of a full React app.
In terms of infrastructure, we have three clear choices: Docker, Render, and GitHub Actions.
Right. Docker solves that ancient "it works on my machine" problem by packaging your app into a guaranteed container. Render is the simplest PaaS, or platform as a service, for deployment. It lets you define your infrastructure as code, which we love. We prioritize its simplicity over the complexity of something like Kubernetes just for speed and ease of maintenance.
And GitHub Actions serves as the CI/CD automation robot. Can you clarify that a bit?
Yeah, CI/CD stands for a continuous integration, continuous deployment. GitHub Actions is just the automation layer that handles all the automated testing and deployment when you push new code. And on top of that, we use CodeRabbit for automated AI code review, which specifically checks for AI-generated code inconsistencies, which is something traditional bots often miss.
Finally, for privacy and local experimentation, what's the game-changer tool?
Llama. This tool makes it so simple to run any open source large language model like Llama 3 or Mistral on your own local machine. Before Llama, running these models was technically complex. You needed deep system knowledge. Now it's a simple, reliable command line interface. It really changed the game for local experimentation and privacy. And alongside Llama, you'd use Open Web UI, which is a local self-hosted version of the ChatGPT interface, and maybe SeerXNG for local web search that aggregates results without relying on external APIs, perfect for running fully private RAG agents.
So let's synthesize the major takeaways from this highly focused, proven stack.
First, AI first is the future. It's not an add-on, it defines how software is going to be architected. Second, focus rigorously on capabilities over chasing new tools. Solve the problem first. Third, and this is big, start simple. Use Streamlit before React. Use a single agent before you bring in LangGraph.
And most critically, find what works, like this stable set of choices, and minimize the time spent just jumping between different tools. This stack really provides a clear, reliable reference point when you feel that initial overwhelm.
It is stable, it's reliable, and it's tested for AI-first development in 2026. Use it as your clear reference guide.
And to leave you with one final thought to mull over, while retrieval-augmented generation gives agents basic facts, the true complexity and potential of knowledge graphs, powered by tools like Neo4j, go far beyond simple document retrieval. It's the key to modeling, querying, and truly understanding these highly complex, multi-layered relationships that are hidden within massive corporate or scientific datasets. That might just be the next great frontier for the most advanced autonomous agents.